Well, class, today you're going to be looking at the different forms of energy and how they transfer from one type to another. Because there's a lot on every screen, unfortunately, you don't get to see my face in this video, but you do get to hear my voice. So that should comfort you a little bit, make your day a little bit better. So we're going to look at this question. How can we demonstrate energy transformations? For example, a flashlight battery changes chemical energy into electrical energy into light energy. So how does that happen? When we look at energy transformations, you may also hear it called energy conversion, where energy is changing from one form to another. So you can see the picture there as the flow of one type of energy to another type of energy, from the radiant sunlight to the solar panels, changing it to a chemical form in the battery, to electrical, to the light, back to radiant as that light bulb shines light down on the table. And when we talk about these, we need to remember that energy in equals energy out. We call that the conservation of energy. It means that energy can neither be destroyed nor created. And so sometimes we think of energy being used up. Well, it's not really being used up, it's just transferring from one type to another. Energy doesn't just disappear, it just transfers from one type to another type of energy. Now, it may transform into multiple other types. And so, if you measured any one of those, it may seem like some of it has disappeared, but energy can be lost to things like heat and sound when it comes to friction. So, if you added up all the transformations that happened, they would be equal on both sides. So, an example there, electric energy converts to heat energy on a stove. It's going to be equal on both sides. So we've already looked at the type of energies this week, and so if we have potential energy, um, it's remember that's the energy that's stored in an item. And so some examples as we're looking through these today of what potential energy can take a form of. It can be mechanical, it can be chemical, it can be nuclear, or it could be electrical. We've also looked at kinetic energy. Remember, kinetic energy is energy that's in motion. And so some of those forms of kinetic energy are the same as the forms of potential energy. Some are different. So mechanical can be either. Radiant is going to be a kinetic energy. Electrical could be either. And thermal is going to be kinetic. So if we kind of see it as a breakdown like this of different types of energy, this may be good for you to remember and even take note of for the assignment tomorrow. You'll kind of find this helpful. All right, so as we talk about energy transformations, let's look at some of those different types of energy. We'll look at mechanical energy first. Mechanical energy in its kinetic form is the energy that a body possesses because of its motion caused by gravity or elasticity. And so it's moving. If something's moving, it's mechanical energy. Flowing water, winds, an arrow shot from a bow, bouncing on a trampoline, all of those would be mechanical energy. Mechanical energy can also take a potential energy form. It's energy that a body possesses because of its position, where it is because of gravity or its elastic potential. So, a book on a table, a compressed spring, or a rubber band pulled back are all examples of mechanical energy in its potential form. As soon as it's able to be moved, it starts moving and it takes on mechanical energy in its kinetic form. So, mechanical energy, the big thing, if you remember that if something's moving, it has mechanical energy. That's the way you're going to see it most of the time. Mechanical energy is also sound. Sometimes some of the stuff we'll look at list this as a separate form of energy, but for our purposes in this class, we're going to label it under mechanical energy. Sound is mechanical energy in its kinetic energy form. It's energy in the form of wave motion. And so if you think of vibrations spread in all directions as one vibrating object touches another, causing it to vibrate. And so as I'm speaking, it is moving the air molecules in front of my mouth, which the speaker picks up or the microphone picks up. And then as the computer plays it back to you, that speaker vibrates, vibrating the air to your ear, to which you can hear my voice. And some examples of that would be a drum, a tuning fork, talking, all of those examples of sound energy. Uh, Energy transformations also come into thermal energy. Now, thermal energy is going to be kinetic because the molecules there are moving, they're speeding up. It's also referred to as heat energy. It's the total energy of atoms and molecules that are constantly in motion. So when we talk about temperature, temperature is really just a measure of the kinetic energy in an item. And so a burner on a stovetop turned on is going to be thermal energy. A hot cup of cocoa or coffee or a fire, all of those things are going to be um, thermal energy. And remember, thermal energy is kinetic. So moving on, energy transformations also take the form of radiant energy. Radiant energy as well is going to be kinetic energy because it is a wave, which we'll look at later on this year. It's also referred to as solar or light energy. It's energy caused by the movement of electromagnetic waves. Some examples of that would be a light bulb, the sun, or microwave. All of those use radiant energy. We also have electrical energy. Electrical energy in its kinetic form. Now, the moving electrons from one point to another in a conductor. So, wire that carries electricity. That electricity is in its kinetic energy form. We also have lightning would be a form of kinetic energy or of electrical energy in its kinetic form. Electrical energy can also be in a potential energy form. It's stored electrons that are not moving. So when they're just waiting to be moved, that's going to be in its potential energy form. An example would be a light bulb turned off. That they're there waiting to move. They're just being kept from moving as that switch or that circuit has been broken. A stove turned off, power outages, all of those would be examples of electrical energy in its potential energy form. We also have chemical energy. Chemical energy is potential energy. And so it's not doing anything yet, but it has the potential for it. Energy stored in chemical substances. And so you can see some examples there on the side. A fuel would be chemical energy in its potential energy form. Explosives, food. As you eat the food, your body reacts with it, which allows it to release energy for your body. But as it's in that food form, it's still chemical. Batteries are an example of that, or wood. And so all of these have chemical energy stored in them that can be used. And we have nuclear energy. And so nuclear energy is also potential energy. We'll look at this a little bit further next week, but it's also known as atomic energy. The energy is stored in the nucleus of an atom. And so we'll talk about fission and fusion and what the difference between those is. But each of those deals with nuclear energy that's stored in the atom. It can be released by fusion, combining atoms in the nuclei, or fission, splitting atoms in the nuclei. So you'll need to be able to remember the difference between fusion and fission as we continue to study nuclear energy next week. And so nuclear power plants is a great example of that. The sun would also be one. So let's see if we can follow the energy flow in these examples. In this example, we have mechanical energy from the wind. That wind moves those blades, which is mechanical energy as well, turns the blades. And then that blade turns the pump that's there to pump water out of that well. And so even though they're all mechanical energy, you see that it still transfers from one type of mechanical energy into another. And so let's look at this one. If we can follow the energy flow from this, we have radiant energy from the sun. That transfers to electrical energy in that solar panel, carrying that electricity across those wires into electrical energy on the wires, and then sound energy or mechanical energy with the music playing. All right, just do one more here. We'll actually do a few more. Can you follow the energy flow of this candle? It's chemical energy, the potential energy that's there in the candle with the wax as a fuel turned to thermal energy. with the burning wick. Also, radiant energy with the light. And so that's the example where I talked about it could transfer to two different types of energy. That chemical energy transferred to two different types, thermal and radiant. As this deer is getting its fuel, let's look at it. Radiant energy from the sun is shining down, giving chemical energy in photosynthesis that takes place. It makes the plants grow to chemical energy as food for the deer. See, in this one, the lightning bolt is electrical energy, transfers to thermal energy in the fire as it hits the tree and causes it to burn. And also, there'd be one more there that would be light energy or radiant energy as the fire produces light. The battery with the light bulb, batteries are chemical energy. And so there's acid in the battery that's waiting to react. And so it has chemical energy that transfers to electrical energy, moving those electrons across the wire to radiant energy in the light bulb. Also would be thermal energy because of the heat that the light bulb produces, even though that's not its intended effect. Then as we look at a reactor, this is one that we use regularly without even thinking about it. So we see the nuclear power plant. We have a nuclear energy in the process of fusion as the reactor reacts there on the far left-hand side of the screen, transfers to mechanical energy as that turbine moves, going to electrical energy, going across the wires there to that city where it produces all kinds of different energy as far as radiant energy for lights, back to mechanical energy to move things, to thermal energy for a stove, all those things that are happening in that city. So that gives you some different energy transformations and what those look like and how they move from one to another. And so make sure you get those down in your notes to be able to refer back to, and you'll be using those over the next couple of days as we continue to work through energy transformations.